Hello, Assalamualaikum. My name is Iza Azra binti Ahmad Srifan. I'm from J4EM 103E and my matrix number is 2019, 211 and 798. In this video, I'm going to conduct an experiment called Flywheel Experiment. So let's get started. Firstly, measure the dimensions of dates and axle using measuring tape. Measure the thickness of the dates and the length of the axle, and repeat the measurements and take average result. Mark a reference line to record number of turns of wheel of axle. Hang the weight hanger at the string holder, then wind the string around the axle. Record the number of turns starting from the lowest point where the hanger almost touched the floor until the end of the string reached the highest point. Make sure the string holder does not collide with the dates. Suspend 0.4 kg of load on the hanger. Release the load from rest at the highest point and record the time until the load reaches the minimum. Repeat steps 1, 2 and 3 with every 0.4 kg increment until 2 kg. Draw the free body diagram and kinetic diagram for the flywheel and weight. So this is the free body diagram and kinetic diagram for the flywheel, and then at the bottom is the free body diagram and kinetic diagram for the weight. Compare and discuss the results of the drop time and moment of inertia for various weight of the flywheel apparatus using theoretical equation, and compared to the measurement in the experiment. Moment of inertia for experiments and theoretical does not have much difference but not accurate enough. For both the experiment and the theoretical, the percent error from the lowest is about 4%, and then the highest percent error is about 11%. Give your comment or suggest at least 4 cause of errors that may affect the results of the experiments. Firstly, the string holder collide with the dates when wind the string after reach the highest point, causing an inaccurate number of turns. Next, forget to mark a reference line. So when release the mass from rest, it will affect as the existing number of turns that is recorded earlier. Moreover, the stopwatch is pressed lower than the weight hanger when it is released, causing to be an incorrect value of time taken. Lastly, the dimensions of the dates and axle is not measured properly. That will cause inaccurate value of diameter of the dates and the axle. In conclusion, to verify Newton's second law for the rotational motion, which is moment equals to mass moment of inertia times Swiss angular acceleration, is achieved. This can be verified using different loads and measuring the resulting acceleration for each as function of the accelerating moment. From this concept, we can determine the moment of inertia of the dates and the axle from experiment by using mass moment of inertia equals to half mass times with radius square. To determine the frictional moment to overcome the friction, and to determine the moment of inertia using the dates and the axle using theoretical equation are also accomplished. We can find the moment for a dates and an axle for the experimental by using a formula of moment equals to max moment of inertia, the total for the dates and axle times with angular acceleration. And for the theoretical, we can find it by using a formula of moment equals to mass times with radius times with gravitational acceleration minus acceleration. One of the safety precautions in this experiment is repeat the measurements for the disc and axle for 3 times and get the average results. One of the improvements that can be done in the experiment is by using an electronic sensor at the end of the axle. So the sensor will automatically count the number of turns. This will deduct the human error, such as mistaken in counting the turn. So that's all for me. Thank you.